So let us explore what's shown here in this animation. So these are satellite-derived images, distributions. Okay? The top one are sea level anomalies, okay, derived from so-called satellite altimeters. The bottom one are sea surface temperature anomalies. So what an anomaly is you look at the average conditions and you only look at differences compared with the average condition. Okay, and then you have positive anomalies or you can have negative anomalies. So in the top image, and this one is just the starting image, a snapshot, everything red means a sea level elevation 10 centimeters above normal or average conditions, and blue means 10 centimeters below. And here you can identify high pressure and low pressure systems. In the bottom image, red means it's 1 degree warmer compared to average, and blue means 1 degree colder. Okay? So now this movie, and it's a little bit hard to see, there's a time information in the middle. It starts 1996, 1st of January. It actually runs for 3 years and captures the El Nino effect that we see at the 1997, 98 El Nino effect. And let's have a look at it. I just let it start it. Okay, so you can see that, and you can see there are some anomalies developing. Okay, and now we are July 96, September 96, October 96, and now we're going into 97. And there's something starting, and there's the El Nino event. Here at the top and the bottom is a significant anomaly starting. Okay, and sea surface temperature anomalies are correlated with sea level anomalies. Okay, and this is the big El Nino event. Let me just stop this animation. Just go back a little bit, and let's just try to find the time when it actually starts. So let's have a look here. Let's have a look exactly in this time. And you can actually identify in the sea level anomaly, this is December 1996. You can identify not much in sea surface temperature, but you can identify a positive anomaly in the sea level anomaly. And it is actually the subtropical, the tropical cyclone pair is actually what creates this anomaly, because there is the Ekman transport moving water towards the equator, and this is what kicks off an equatorial Kelvin wave. And if I now start the movie, you can see again it moves over to the east, and at the same time you get an anomaly in temperatures here, because the upwelling that exists in the area is suppressed. Okay, let's just get this started again. Let me try to find the right button here. Now it starts. There is the it swings a little bit back and forth for some reason, but it hits the eastern coast, and here we go. Here we see, and I stop now. And the white that you can see is actually beyond the range shown. So it's more than 2.5 degrees. And we know from the other observations, actually 4 degrees warmer than you normally have. Okay, so this is the famous movie of satellite observations, which captures the 1997-1998 El Nino. Okay, and if you see that, with all the additional knowledge that you have, you can also now infer that the rainfall that you normally have in the western Pacific Ocean and the equatorial regions there has shifted over the central parts on the Pacific, and the upwelling is suppressed in the eastern bit. So it's always the entire chain of processes that happen at the same time. You always have to keep that in mind. So if you look at this, you can link it to all the other features that happen during an El Nino event. All right.